Hi, this is a video to review double grouping and factor by grouping. We're going to start with an example. We use double grouping when we have four terms. Terms are separated by plus and minus signs. So 1, 2, 3, 4. We have four terms, so we're ready to use double grouping. Notice we have the highest degree first, and then in order from the highest degree, which is 2 second degree, the exponent, in order down 1, 1, 0. So we want to have it in standard form. We're going to separate our four terms into two groups of 2, and we are going to factor out the greatest common factor. So 7 and 35 are both divisible by 7. X squared and x are both divisible by 1x. They both have at least 1x. When I divide 7x squared by 7x, I'm left with just x. Check to make sure by distributing what is 7x times x, it's 7x squared. So yes, that does get me back to 7x squared. And then to see what goes in the other side of the parentheses, divide negative 35x by 7x, and you get negative 5. No x because x divided by x cancels out. Again, you can multiply what is 7 times x, what is 7x times negative 5. Does that get me back to my original 7x squared minus 35x? Yes, that's one way to check to make sure you are on the right track and you haven't made any mistakes. Now you want to do the same thing with the other group, 2x minus 10. 2 and 10 are both divisible by 2, but they do not have an x in common. So all we have here is 2, and when we divide 2x by 2, we get x, and when we divide negative 10 by 2, we get negative 5. Now, we know that this polynomial can be factored when we end up with the same parentheses. We have to have the same parentheses to use the factor by grouping method correctly. If you do not get the same parentheses, and there's no way to get the same parentheses by changing the sign of what you're factoring out or by making sure you have the greatest common factor, then we would say our polynomial is prime. This polynomial is not prime because we do get the same parentheses, which means we can give a final answer. So we pull out the parentheses they have in common, x minus 5. We've pulled that out, and then the other part of our answer is what's left, the 7x plus 2. 7x plus 2. So my factored form is 7x plus 2 times x minus 5, but because multiplication is commutative, we could write it either way. So that is a review of factor by grouping, and it also discusses prime. So if I were going to ask you, hey, is this polynomial prime? You'd start off by grouping it. You'd find the greatest common factor of 12 and 42. I think that's 6 because 42 is not divisible by 12. And then x to the fourth and x squared, they both have at least 2 x's. So I'm going to pull out 6x squared. What's left inside the parentheses, divide both of them by 6x squared. What is 12x to the fourth divided by 6x squared? 12 divided by 6 is 2, and x to the fourth, take out x squared, and you're left with x squared. So we get 2x squared inside the parentheses. And then what do we get when we divide 42x squared by 6x squared? The x squareds cancel, and we're left with just 42 divided by 6, which is 7. So 2x squared plus 7. Now look at the other group and try to factor. You've got 42x squared plus 14. They're both divisible by 2 because 14 is not divisible by 4. So we divide them both by 2. They do not both have an x, so we can't pull out an x. So we divide them both by 2, and 4x squared divided by 2 is 2x squared, and 14 divided by 2 is 7. Over here, just to recap, I was having an issue with my pen, so 12x to the 4th divided by 6x squared is 2x squared. 42x squared divided by 6x squared is positive 7. Now, are they prime? Is this a prime polynomial? Is that last polynomial right there a prime polynomial? No, it is not, because when we factor by grouping, we did get the same number inside the parentheses, the exact same thing inside the parentheses, which means we can factor this as 6x squared plus 2 times 2x plus 7. One more example, we've got factor this expression by grouping, and what is the resulting expression? So I'm going to look at this problem right here. Factor by grouping, and what is the resulting expression? So again, you're going to divide it up into 2 groups of 2 terms. So I'm going to take my negative 8x cubed minus 2x squared minus 12x minus 3, and we're going to divide it up into 2 groups of 2 terms. Now we're looking for the greatest common factor for each group. Here we've got x cubed and x squared. You want to look at numbers and variables. So you got negative 8 and negative 2 are both divisible by negative 2. X squared and x cubed have at least 2 x's each. So I know that's the greatest amount they have in common. And then you've got negative 12 and negative 3 are both divisible by negative 3, but they do not both have an x. So now what do we get when we divide out the greatest common factor? We get negative 2x squared, our greatest common factor on the outside. Negative 8 divided by negative 2 is positive 4. X cubed divided by x squared is 1x, just x to the first. Negative 2 divided by negative 2 is a positive 1. X squared divided by x squared is 1. So 4x plus 1. Do the same thing over here. We factored out negative 3. Negative 12x divided by negative 3 is positive 4x. And negative 3 divided by negative 3 is positive 1. Now you're left with 2 binomials that are the same. So the inside parts are the same. And we are able to write the binomial they have in common. So that's the one inside the parentheses. Write that one down. That one they have in common. So we know this is not prime because they have that in common. And then we can bring down what's left. Negative 2x squared minus 3. So now we're looking for negative 2x squared minus 3 and positive 4x plus 1 to select our correct answer for the resulting factored form. Thanks for watching. Have a good day.